Hi everyone, welcome back to our YouTube channel. Today, we're diving into one of Europe's most ambitious defense projects, the FCAS fighter jet. Also known as the Future Combat Air System, the FCAS is a sixth-generation fighter aircraft currently being developed by a joint effort between France, Germany, and Spain. This isn't just another stealth fighter, it's a complete system of systems, blending manned and unmanned platforms, artificial intelligence, and next-generation connectivity to redefine the future of air combat. The FCAS program is led by some of the most advanced aerospace companies in Europe, Dassault Aviation, Airbus, and Indra Sistemas. Dassault is responsible for the new generation fighter NGF, which will be the core manned aircraft of the FCAS. Airbus is taking charge of the remote carriers, drones and unmanned systems that will support the fighter jet in combat, and the overall system integration. Indra is playing a key role in the sensor and electronics domain. Together, these companies are combining their technological expertise to challenge global competitors like the American NGAD and the British-led Tempest program. One of the most revolutionary features of the FCAS is its concept of system of systems. The NGF won't fly alone. Instead, it will be accompanied by a network of remote carriers, highly autonomous drones that can scout enemy positions, jam radar, launch missiles, or even act as decoys. These drones will be tightly connected to the NGF through advanced secure communication systems. The entire network will be powered by artificial intelligence to manage data in real time, allowing the pilot to make lightning-fast decisions on the battlefield. The FCAS fighter itself is expected to feature cutting-edge stealth capabilities. It will have a sleek, tailless delta wing design optimized for low radar cross-section, similar to other sixth-generation concepts. Internally housed weapons bays will minimize radar signatures, and its engines will be built with advanced cooling systems and infrared suppression to reduce heat detection. The cockpit will be outfitted with a futuristic human-machine interface, possibly incorporating voice commands, eye-tracking systems, and even neural links that enable faster pilot responses. Unlike today's fighters that heavily rely on radar alone, the FCAS will feature a wide array of multispectral sensors that can detect enemies across electromagnetic spectrums, from infrared to passive radio frequency. These sensors will be fused using AI to present a complete 360-degree situational awareness to the pilot. Moreover, the data gathered by one jet or drone will be instantly shared across the fleet using combat cloud networking. This digital ecosystem enables collaborative operations, such as swarming attacks or coordinated defense strategies, all managed with minimal human input. Another key area of focus in the FCAS program is interoperability. The fighter jet and its associated systems will be designed to work seamlessly with NATO allies and across various military platforms, including naval vessels and land-based command centers. This ensures that FCAS doesn't just serve the Air Force, it becomes a central node in joint force operations. When it comes to propulsion, the engine for the NGF will be developed by Safran, France, and MTU Aero Engines, Germany, two powerhouses in aerospace engineering. The engine will be built not only for raw power but also for energy efficiency, supercruise capabilities, sustained supersonic flight without afterburners, and minimal thermal and acoustic signatures. The FCAS will likely feature variable cycle engines, allowing them to switch performance modes depending on whether stealth, speed, or fuel economy is needed. The timeline for the FCAS is ambitious. The demonstrator version of the NGF is expected to take to the skies around 2029, with full operational capability targeted for 2040. While that may seem far off, developing a sixth-generation combat aircraft from scratch is a highly complex endeavor involving years of testing, integration, and technological breakthroughs. Already, significant progress has been made with wind tunnel tests, virtual simulations, and early prototype components. Strategically, the FCAS is about more than just a new jet. It's a symbol of European defense independence. As the world moves toward multipolar military competition, European nations recognize the need to reduce dependency on U.S. platforms like the F-35. By developing their own cutting-edge systems, France, Germany, and Spain aim to strengthen their sovereignty and solidify their position as leaders in global aerospace innovation. The economic and industrial impact of FCAS is also enormous. It supports thousands of high-skilled jobs and fosters innovation in sectors ranging from aerospace and electronics to cybersecurity and AI. Small and medium enterprises across Europe are contributing technologies to the program, ensuring broad-based development and knowledge sharing. The FCAS program is also expected to drive technological spillovers into the civilian sector, including in aviation, telecommunications, and robotics. Despite the ambition, the project isn't without challenges. Differences in national priorities, industrial politics, and budget allocations have led to delays and negotiation deadlocks in the past. There were periods of tension between Dassault and Airbus over control of key technologies, but recent updates indicate that these hurdles have largely been resolved, with all stakeholders reaffirming their commitment to the timeline and objectives. In comparison to its future competitors, the FCAS will go head-to-head with the U.S. Air Force's Next Generation Air Dominance (NGAD) platform and the UK's Tempest, now part of the Global Combat Air Programme with Japan and Italy. Each of these 6th-gen platforms shares common traits: stealth, manned-unmanned teaming, AI, and hypersonic potential, but their design philosophies and mission focuses differ. Where NGAD focuses on air superiority over Pacific distances, and Tempest emphasizes modularity and export, FCAS aims to be the backbone of Europe's integrated defense ecosystem. At its core, FCAS isn't just about building a better fighter, it's about creating a smarter, more connected, and more resilient combat force. The lessons learned from Ukraine, Syria, and other modern conflicts have shown that data, speed, and electronic warfare are now as important as brute strength. FCAS embraces that future, where a single jet can act as a command node, a stealth attacker, a data hub, and a team leader for robotic allies, all at once. As the development continues, the FCAS project remains a fascinating example of how far military aviation has come, and how far it's about to go. For enthusiasts, strategists, and technologists alike, the FCAS promises to be one of the most exciting and game-changing aircraft projects of the 21st century. Thanks for watching, and make sure to subscribe for more deep dives into the world of advanced aviation and military tech.